Supply chain risk basics. In general, enterprise risk management can be defined as the field of activity seeking to eliminate, reduce, and generally control pure risks. While the terminology can differ from author to author, a systematic risk management process usually comprises the stages of risk identification, risk analysis, risk management in the narrow sense, and risk monitoring. The overall objective of this process is to determine, implement, and monitor an optimal mix of measures to avoid, defer, reduce, or transfer all relevant risks. The determined mix is considered to be optimal if the remaining amount of risk is in line with the firm's risk preference and corporate strategy. This generic risk management process was transferred and adapted to the supply chain context. Supply chain risk is defined as the likelihood and consequence of events at any point in the end-to-end supply chain, from sources of raw materials to end use of customers, and supply chain risk management as the coordination of activities to direct and control an enterprise's end-to-end supply chain with regard to supply chain risks. This generic definition is articulated and developed by many of the supply chain risk professionals, often focusing on its application in particular industrial sectors or business contexts. I have deliberately chosen not to promote a definition for the term risk for two reasons. Firstly, seeking agreement on a definition has proved problematic for most fields of study across significant time periods. And secondly, prescribing a particular definition is likely to prove counterproductive in generating and encouraging the different perspectives and approaches adopted. However, risk itself within the context of the supply chain may be categorized in a number of dimensions. First, disruptions to the supply of goods or services, including poor quality, which cause downtime and consequent failure to satisfy the customer's requirements on time. Second, volatility in terms of price may result in difficulties in passing on price changes to the customer and potentially have consequences in lost profit. Poor quality products or services, either upstream or downstream, may impact on the level of satisfaction of the customer, with consequences for future revenues and possibly more immediate claims for financial compensation. The reputation of the firm, often generated by issues not directly related to the supply chain itself, may pose risks. Inadvertent comments by senior executive or the failure to endorse certain protocols may damage the reputation of the organization. Now let's examine the components of supply chain risk management. The components of supply chain risk management may again be differentially defined in terms of the subdivision of the particular strands, although most definitions would encompass the following. First, risk identification and modeling, incorporating the sources and characterization of risks, what may trigger them, and the relationship to the supply chain functioning effectively and efficiently. Risk analysis, assessment and impact measurement in terms of likelihood of occurrence and potential consequences. Risk management, generating and considering alternative scenarios and solutions, judging their respective merits, selecting solutions, and undertaking the implementation. Risk monitoring and evaluation, monitoring, controlling, and managing solutions and assessing their impact on business performance outcomes. Organizational and personal learning, including knowledge transfer, seeking to capture, extract, distill, and disseminate lessons and experiences to others within the organization and its associated supply chain members. The supply chain risk management approach comprises a set of interacting considerations or activities in relation to the supply chain. The essence of supply chain risk management is taking a more proactive approach to managing risks in the supply chain in advance of their occurrence. This does not necessarily ensure that all such potential risks can be identified in advance, or if identified, sufficiently well resolved to prevent some or all of the negative consequences. In summary, supply chain risk management, like other management systems, is dependent on good quality management in terms of knowledge, abilities, experiences, and skills. The concepts, tools, and technologies provide support but are unable as yet to replace the judgments required in most risky decision situations. The changing face of supply chain risks. Supply chains have never been sophisticated and as a result so vulnerable to risk. The lean production method and just-in-time inventories, less vertical integration, dependence on single-source suppliers, and increased reliance on low-cost and cost-reducing suppliers, often located in unstable areas, all contribute to a higher level of risk. Many supply chain threats are not local to an organization. Globalization has led to lower production costs resulting from cheaper labor and materials, along with added risks resulting from extended supply chains, decreased reliability, language barriers, suppliers further outsourcing the work, political unrest, shutdowns at shipping facilities, and economic instability. The end result is potentially significant and long-term supply chain disruptions that have the potential to cascade across the organization and result in the loss of business and customers, severe long-term damage to reputation, and legal action. Nowadays, countless production companies actually produce very little. Rather, they purchase components and parts from multiple suppliers for assembly and distribution, creating a tremendous dependency on their supply networks. The ongoing push for a smaller physical footprint is often accomplished by streamlining the company's facilities by removing operations and locations seen as being redundant, inefficient, or unnecessary. Future developments in supply chain risk management. Attempting to forecast future developments in any field is a risky business in itself. However, most risk professionals, in presenting their research and practical experiences, have either directly or indirectly implied the developments that they anticipate or see as essential in their specialist areas. Here is a summary of these points. First, developing new frameworks to capture the more complex, dynamic, continually evolving, and multi-faced nature of today's supply chains. Increasing attention towards the application of supply chain risk management in the smaller businesses context. Identifying contingency factors and the generation of appropriate models and decision heuristics. Increasing attention towards developing appropriate performance measurements and methods to assess the impact of risk and the associated supply chain risk management actions in both quantitative and qualitative metrics. Applying network theory and concepts to understanding the behavior of networks and the organizations operating within them. Developing greater insights into the approaches to engender improved relationships and trust between supply chain partners and how these might be sustained in global supply chains. Recognizing the inherent attitudes and behaviors of individuals and groups involved in the supply chain risk management process. Emphasizing the development and training of individuals to competently manage supply chain risks in terms of undergraduate, postgraduate, and professional development programs. Providing more in-depth research and development in specialist subfields. Developing and applying performance standards to ensure management of risks where supply chain security is significant. Developing more robust analytical tools and frameworks to support decision makers. Above all, the need remains to provide platforms and vehicles for the interaction, exchange, and engagement between practitioners, policymakers, and researchers in the supply chain management and supply chain risk management fields. In this lecture, we are going to examine the risk management process. The process is based on ISO 31000 covers elements of risk identification, risk assessment, and risk treatment. ISO 31000 is a key building block to our approach. While adapting it to our own purposes, we recognize the need to avoid replicating standards documents, but rather to strive for practices that cover security, crisis, continuity, and recovery requirements enterprises may have. As you can see here, the process begins with identifying internal and external environments. Enterprises may inadvertently overlook internal risks. These may include those posed by a rogue employee, as well as those posed by inadequate policies, strategies, or organizational structures. The external environment in which an enterprise and its suppliers must work will also pose differing risks. For example, some suppliers will face meteorological risks, while others, because of their distance, may have greater transportation risks. Mapping its supply chain can help an enterprise identify the risks it faces and how best to prioritize and address them. To prioritize and address risks, firms will need to identify criteria for determining what may pose a risk to its operations. One potential starting point is the supply chains for the products most affecting firm profitability. Once a firm understands how to identify risks, it may undertake risk identification and assessment, which includes risk identification, risk analysis, and risk evaluation. Risk identification may entail using a list of common risks, including external risks such as natural disasters, accidents, sabotage, or labor uncertainty. Supplier risks such as production problems, financial issues, or subcontractor problems. Distribution risks such as cargo damage, warehouse inadequacies, or supply pipeline constructions. And some internal risks such as personnel availability or facility unavailability. Such process will also involve prioritizing risks by the threat as measured by likelihood and consequence they can pose to a firm's operations. Once a firm has identified and prioritized the risks that it faces, it can devise risk treatment plans. This includes measures to protect the supply chain from risks, plans to respond to events that these risks may cause, and plans to continue operations in the face of disruptions and fully recovering from them. This may also involve determining ways to measure risks and the effectiveness of plans to limit them or to respond to disruptions. Enterprises must also undertake continual communication and consultation as well as monitoring and review throughout this process. Monitoring and review entails not only evaluating the effects of risk treatment, but also maintaining the plan and responding to changes in supplier, processes, and regulation affecting elements of the supply chains. It also entails continually identifying opportunities for improvement. We will explore each of these process steps in the following lectures, from Lecture 4 to Lecture 8. Principles of Supply Chain Risk Management. Efforts to implement supply chain risk management must address 4 principles: leadership, governance, change management, and the development of a business case. Leadership support and guidance is essential to any successful supply chain risk management program. An integrated and engaged leadership team can not only help identify risks well before they cause disruptions, but also provide a quick and thorough response to any incidents that might occur. Ultimately, leadership, reporting, and ownership of supply chain risk should rest with senior management. An effective supply chain risk management team should include leaders from functions such as business continuity, engineering and design, enterprise risk management, finance, governance, import-export, logistics, manufacturing, procurement, quality, security, and so on. Differing functions should have representation on both the executive steering team and the implementation team. It is most effective to have an executive sponsor who is skilled in the area in which the firm faces the greatest risk. For example, if timely transportation of components is the most vital function for a firm, and the one where it may face the greatest risks, then it may wish to have a logistics executive be the executive sponsor of the supply chain risk management team. Corporate culture, including the area that a company most wishes to emphasize to build its reputation, may also determine executive sponsorship for the supply chain risk management team. For example, a manufacturing firm may choose to have a manufacturing executive be the executive sponsor of the supply chain risk management team, regardless of the greatest supply chain risks. One leading firm rose up risks to the chief information officer, to whom responsibility for supply chain risks was originally given. Another has a vice president of risk manager. A leading insurance provider has its chief operating officer assume ultimate responsibility for risk management. In many mid-sized companies, the chief financial officer may have ultimate responsibility for risk management. The team should ensure that risk management processes are embedded into business function processes, so as to ensure proper communication and collaboration on events. Regular meetings of the implementation team can help ensure proper communication, as can less frequent but still regular meetings of the executive steering team. One leading firm briefs its executive board quarterly on supply chain risks and what is being done to address them. Ideally, a firm will have detailed governance procedures for a continuing supply chain risk management team, including those on meeting structure, attendees, standard agenda items, and business process deliverables. Typical agenda items might include process maturity, metrics, compliance, and audits, a review of risks and how the firm is addressing them, and sharing of knowledge and best practices. Supply chain risk management teams should use inputs from lower-level working groups and process users to influence decisions of higher-level executives in determining appropriate resources and priorities for their efforts. In this and next lecture, we are going to examine the first step of the risk management process, internal and external risk drivers. Supply chain risk is about any threat of interruption to the working of its supply chain. Risk may be generated as a result of risk drivers that are either internal or external to the company. The external drivers are the risk areas that are most commonly thought of by managers. This is for exactly the reason that they are external and therefore may be perceived as unmanageable. The risks of unpredictable demand, unreliable supply, and the effects of external shocks in the business, social, and climatic environment are all the areas that we use as scapegoats for unexpected outcomes. The internal drivers of process, control, and mitigation contingency are more tightly under the direction of the company itself and are therefore less obvious as being sources of vulnerability. Making vertical and diagonal connections between the external and internal dimensions areas provides a conceptual breakthrough in understanding how risk is uniquely embedded in the individual company's supply chains. Let's examine the external drivers. First, demand risk. Demand risk relates to potential or actual disturbances to flow of product, information, and in this instance cash emanating from within the network, between the focal company and the market. In particular, it relates to the processes, controls, asset, and infrastructure dependencies of the organizations downstream and adjacent to the focal company. Demand risks is the risk associated with a company experiencing demand that it has not anticipated and provisioned for through its chain to enable it to satisfy its customers' demands or those of its customers' customers. This demand risk can be a failure on either the high or low side to accurately accommodate the level of demand. Demand risks is the most commonly articulated supply chain risk. It is often headlined as forecast accuracy and the bullwhip effect but this is not strictly correct, since true demand risk is about unpredictable events that are outside the tolerance of the company's supply chain to accommodate. Also, the question of demand risk goes beyond the scope of demand volatility to include, for example, the whole area of new product introductions. This has been widely researched and evaluated, as it is a special area of significant demand risk. It is important to note that the consequential liabilities enhance a risk to the company of demand being either substantially greater or less than the capacity of the chain is context sensitive to the situation of the business. So, for example, demand greatly exceeding supply may not be a major strategic risk, as the company could harden prices and reinforce the brand position in the market as being the hot product. Conversely, an inability to meet exceptional demand could be interpreted by large customers as a failure of commitment to its market and cause them to look for replacement suppliers. Demand that is well below expectation is almost always a major threat, since the supply chain will have been provisioned and investments made against the forecasts, so substantial obsolescence may be incurred. At the financial level, some level of demand risk can be accommodated, but more may threaten the company's existence. Evaluating the resilience of the chain to demand-side risk is therefore a key capability. We need to understand the scale, extent of the risk, its cost, should it occur, and the duration for which the business is exposed. Clearly, this needs to include an ability to synthesize and assess the consequential impacts, such as lost customer confidence and the effect on sales or of other ranges. Software solutions abound that address the need to improve forecast accuracy, and developments in supply chain design are aimed at avoiding the worst effects of unpredictable demand through postponement strategies. Insofar as these are effective in increasing the ability of the business to anticipate volatile demand, they mitigate against the worst experiences of demand risk. The effective operation of such solutions then becomes internal to the company and is essentially a control risk. Supply risk. Supply risk is the upstream equivalent of demand risk. It relates to potential or actual disturbances to the flow of product or information emanating within the network upstream of the focal company. Therefore, it is risk associated with a company's suppliers or suppliers being unable to deliver the materials the company needs to effectively meet its production requirements, demand forecasts. The reality is that supply risk is almost invariably thought of as a failure of their processes and controls. Most often this is about breakdown, shortage of materials through the supplier's chain, quality and rework issues, or poor planning and hence committing to unreal delivery dates. It may be thought that an aspect of this risk arises when the supplier is unable to meet unpredicted demands placed on it by its customer. This is unreasonable, since the key tests of supply-side failure are about whether the demand was accepted by the supplier as being within the capacity of the company's supply chain, and then whether it met them on time and to quality. The consequences of supply-side failure are usually financially debilitating, resulting from a series of issues including schedule adherence, technical concerns, and quality questions. Typically, the company's consequences of supply failures will include loss of output, revenue, and profit, customer dissatisfaction. Another common experience of supply-side failure is supplier bankruptcy or withdrawal from the market. These events often happen without formal notice, causing considerable disruption. However, they can usually be anticipated with the right intelligence systems in place. Contingency planning for such an event is an important control process inside the company, and this will be described later. Supply risk extends as well to logistics service providers who fulfill the links in the chain. If a supplier's product is available, but the logistics service provider is late delivering or loses the product, the company will experience supply variability, albeit usually of a temporary nature. Environmental risk. Environmental risk is the risk associated with external and, from the company's perspective, uncontrollable events. The risks can impact the company directly or through its suppliers and customers. Examples would include port and depot blockades, preventing shipment of products to stores. Another could be the closure of an entire industrial area due to fire or chemical spillage. Environmental risks with a wider impact would be events such as earthquake, cyclone, volcanic, or terrorist activity. In these cases, the business might be disrupted in terms of its ability to ship, as well as causing an adjustment to level of demand. Economic slumps would come into the environmental category, and many markets have some experience of dramatic reversals of fortune leading to business failures and bankruptcies. The economic shocks of events such as currency devaluations and stock market fluctuations are all environmental in nature. Government actions around taxation and regulation can influence the market or the supply landscape significantly, and although there is usually notice of this, some areas of business, for example tobacco, have been impacted by changes of this type. Finally, some companies are exposed to targeted sabotage such as product tampering, which can have dramatic effects on demand and the sustainability of the business. Some of these risks are sufficiently remote to be insurable, while others are not. Business interruption insurances can militate against some of the costs, but many of these factors are outside the insurance net, and the return on a claim is unlikely to compensate the true loss of market. In this lecture, we will continue with the internal risk drivers. There are several types of internal risk drivers we are going to examine: process risk, control risks, and mitigation and contingency risks. Let's start off with the process risk. Processes are the sequences of value-adding and managerial activities undertaken by the company. The execution of these processes is likely to be immediately dependent on internally owned or managed assets and on a functioning infrastructure. Process risk relates to disruptions to these processes. Process risk is risk associated with the variability of a company's operational processes. It pertains to execution, whereas control risk relates to planning. The two dimensions are inextricably linked and interdependent, but nevertheless, it is useful to consider separately events that may go wrong physically and operationally versus those from a planning and management perspective. There is a wide range of potential for failure inside the company in the same way as with suppliers, supplier risk and customers' demand risk. Again, these risks impact both on the ability to create and satisfy customer demand. The result is that sales and profitability will fall below expectations. A breakdown in the company's processes can be experienced in some or all of these ways: variation in manufacturing yields, equipment and hence utilization, quality and rework issues associated with internal manufacturing and technical processes, warehouse operations leading to fulfillment issues, business and supply chain systems failures, transport failures where the operation is under the control of the focal company. Failure to deploy and utilize the assets and resources of the business is largely unrecoverable, as the time value of the asset perishes when it is not used. Companies with extensive operations experience have generally reached equilibrium in their operations, where the processes have been mastered and there is a degree of predictability. ISO controls are good evidence of this achievement, as are sound internal performance management procedures. The greatest process risks are commonly associated with introducing new products, technology, and customers, as well as changes to facilities and operating methods. A common maxim of risk management is not to undertake too many new initiatives at one time. Control risk. Controls are the assumptions, rules, systems, and procedures that govern how an organization exerts control over the processes. In terms of the supply chain, they may be order quantities, batch sizes, safety stock policies, and so on, plus the policies and procedures that govern asset and transport management. Control risk is therefore the risk arising from the application or misapplication of these rules. It is associated with the company's planning and management activities, including the quality, accuracy, and reliability of its operating procedures and its compliance with regulations and standards. This is a broad category of risk which, as explained previously, is the planning and control perspective of the process risk or execution. Control risks are almost invariably self-induced by either omission or commission. They could include systematic forecast error as a result or flawed or non-existent sales and operations planning, inventory control accuracy, inadequate or unsound scheduling methods, accounting and financial control failures ranging from credit control to not securing the capital necessary to continue to fund the company, and failure to comply with the regulatory environment leading to external actions to impose fines or closure. Mitigation and contingency risks. Mitigation is a hedge against risk built into the operations themselves, and therefore the lack of mitigating tactics is a risk in itself. Contingency is the existence of a prepared plan and the identification of resources that can be mobilized in the event of a risk being identified. Mitigation contingency is an internal driver that can be put in place to compensate for some aspects of supply, demand, environmental, process, and control risks. The classic mitigations in supply chain management are inventory, capacity, dual sourcing, distribution and logistics alternatives, and backup arrangements. Inventory is a classic example. Safety stocks are put in place to compensate for unusual demand or supply within the lead time to recover the situation. As an example, a pharmaceutical company with a single source of its active ingredient for a drug, where the supplier was located on an earthquake fault, held 18 months of inventory as contingency. By contrast, a retailer might have worked out that the temporary loss of one of its 4 depots due to fire would not interrupt the business severely, since product can be rerouted via the others, and the likelihood of 2 burning down at the same time is remote. However, if that depot had single national coverage, it would be wise to have a rehearsed contingency plan, if not actual backup. Now let's examine the connection between risk elements. The easiest way to demonstrate how the risk elements are connected is by examples, and the following points are a platform for arriving at an initial understanding. Let's now take each risk area in turn. First, demand risk. Many companies in manufacturing and distribution are dependent on a small number of customers for a large part of their revenue. The loss of these customers, highly volatile ordering patterns, or delays in new products, call-offs, represent serious risks for these companies. However, such risks can be at least partially offset and managed through the existence of good controls for account management, for collaborative forecasting with customers, and for commercial terms that recognize the cost of volatility. These controls can extend to the way in which suppliers are managed to connect them to the potential for demand volatility. Such risks can also be managed by process measures to reduce lead times and increase supply responsiveness. Supply risks. Many companies are equally dependent on just a few suppliers, which may provide unique products via specialist tooling or technology. or which may be simply very large in their trading relationships. Typically, companies buy in goods that represent a minimum of 40% and sometimes as high as 80% of revenues, so disruption to supply would threaten business continuity. Such risks can be at least partially offset by control processes that monitor supplier viability and reliability and that share forecasts and plans with suppliers and gain visibility of their schedules. Mitigation of supply-side risk could include strategic inventory holding, dual sourcing or arrangements to move tooling. Contingency would include the identification of alternative sources of supply and planning for their introduction in the event of failures in the existing base. Environmental risk is a mixture of external risks to the company, its customers and suppliers. It is the most difficult to predict of all vulnerabilities as it spans weather, business environment, acts of war, and so on. Here the obligation on the company is to identify the impacts that could arise based on known hazards from the short term, for example exposure to power failure, through to severe business disruption due to strikes and natural disasters. Environmental risks are likely to impact on both supply and demand, and an attempt to identify such events should extend to these communities. Mitigation is less likely in this area than contingency. For example, the big retailers have contingency plans to fly in fresh food from around Europe in the event of a port or tunnel blockade, while others have emergency fuel capacity to maintain depot operations in the event of temporary fuel shortages. Risk is context sensitive for the company, and the risk elements interact to neutralize or exacerbate the risks. This is a particularly challenging idea since it is very specific to the company and its environment, and it is therefore difficult to make generalizations that will invariably apply. Process risk. Most companies have a core process that is at the heart of their business. For a manufacturer, this will be technical, and for retailers and distributors, this will be in the areas of buying and distribution. Typically, manufacturers are more exposed to process risk than retailers and distributors, with issues of yield, plant breakdown, quality issues, product safety and health questions. For many companies, especially in the areas of food, pharmaceuticals, and engineering, these risks are mitigated through standard procedures such as ISO 9000. They may also be mitigated through safety stock policies and controlled through supply chain visibility and lead time reduction programs. Control risks. The controls that a company applies to its supply chain will impact on its ability to deal with demand, suppliers, and to manage the processes by which the company fulfills demand. Failures in inventory management, demand forecasting, and manufacturing scheduling would all be examples of areas where control breakdowns could lead to risks being experienced. The existence of programs of supply chain performance measurement and key performance indicators and investments in computer systems to assist in the management of demand and scheduling are mitigating measures. Training and people development programs are equally valuable control mitigation measures, as are the existence of standard operating procedures for perpetual inventory management. And last one, mitigation and contingency. The lack of mitigation and contingency measures for the major areas of risk that the company faces is a risk in its own right. The acid test of a company's preparedness is that it has a risk management program in place that has tried to identify formally the risks that could occur in its supply chains and consider its options in relation to them. In this lecture, we will examine the risk assessment, which is the second step of the risk management process. A solid risk management program, from initial deployment to sustainable operation, includes a robust and ongoing risk identification and assessment process. That is, it includes a risk assessment process that is able to evaluate a wide variety of risks over time. The risk assessment process should distinguish between risks that should be included in the risk management process and those that should not. Normal variations in product demand and quality and those that are maintained within acceptable limits do not represent risks that should be included in the risk management process. Characteristics that can cause abnormal variations, that is, those which the supply chain cannot flex and respond to, should be included. Risk identification. Developing an initial risk register, which is a one-time effort, is necessary to identify baseline risks. Too many organizations start a risk management program without knowing what threats the organization faces or what consequences a disruption would have. As a result, they focus too much protecting against the wrong threats or too little protecting against threats that matter. Worse, they may fail to anticipate important threats or fail to recognize the consequences an apparently minor threat may have. Risk identification might begin with brainstorming sessions, previous risk assessment, service, or still other efforts to identify and list potential risks within supply chain processes. A business impact analysis can help a firm evaluate the threats a firm might face and their consequences. Such analysis might start with a worst-case scenario focusing on the business process that are most critical to recover and how they might be recovered remotely. A business impact analysis should identify critical business functions and assign a level of importance to each function based on the operational or financial consequences. It should also set recovery time objectives and the resources required for these. Here are some examples of threats an organization may wish to consider for mitigation. External end-to-end risks, natural disasters, accidents, sabotage, terrorism, political uncertainty, labor unavailability, and so on. Supplier risks, such as physical and regulatory risks, production problems, financial losses and premiums, management risks, upstream supply risks. Internal enterprise risks, operational, political uncertainty, demand variability, personnel availability, design uncertainty, planning failures, and so on. And some distribution risks, such as infrastructure unavailability, lack of capacity, labor unavailability, cargo damage or theft, warehouse inadequacies, and so on. You can find a more exhaustive list in the downloadable resources tab of this lecture. To identify risks, firms should also consider number and location of suppliers. For example, are there suppliers in countries with social unrest, terrorist or drug activity, or high levels of corruption? Number and origin of shipments. For example, have increased quantities or values of shipments pose additional risks. Contractual terms defining responsibility for shipping. For example, firms may specify security controls and procedures for their suppliers. Modes of transport and routes for shipments. For example, firms may ask their suppliers follow certified security procedures for ocean container or truck trailer shipments. Other logistics providers or partners involved in the supply chain, such as packaging companies, warehousing, trucking companies, freight forwarders, air or ocean carriers, who handle the shipments. For example, firms may require that logistics providers meet all certification standards, form an official supply chain security program. Not all possible risks, of course, will threaten organizations equally. Locations are not, for example, equally at risk for meteorological threats for their operations. Organizations may use operational exercises to determine if they have identified all plausible threats for a given location. They may also use such exercises to analyze risks and evaluate their responses to them. The initial risk register, even if including all identified risks for mapped processes, will likely not cover all risks. or even all significant risks to the supply chain. It is just a starting point to identify relevant supply chain risks. Once the baseline risks are identified, the organization should periodically review the status of risks in the risk register, incorporating new risks as they develop and eliminating risks that are no longer relevant. Risk analysis. The risk analysis process should estimate the likelihood and consequences of risks facing a firm and accordingly prioritize them for ultimate treatment. To begin, firms may choose to rank risks events based on a qualitative overall risk level. Such a simplistic approach should only be used for the initial risk register, but provides an easy way to quickly prioritize perceived risks and select those that should receive priority attention. Once an enterprise has identified its top risks, it may use more sophisticated methods, such as the bow tie method, to fully understand the nature of the risk and to rate the likelihood and consequence of inherent risks. And residual risk. The bow tie risk analysis method is a form of cause and consequence analysis, the two dimensions of risk events, and it clearly ties treatment actions against each dimension of a risk event. Let's see an example. A manufacturer may face a risk of shutdown resulting from an earthquake, a fire, a flood, failure of a key supplier, or temporary loss of workers due to an infectious disease outbreak. In analyzing its risks, it may wish to determine the likelihood of each of these events. Likewise, it may wish to rate the consequences of such events. 5-point scales of likelihood, ranging, for example, from less than 5% for the least probable to more than 90% for the most probable, and consequence, ranging, for example, from less than 2% of gross revenue or 4% of net revenue for the least consequential to more than 20% of gross revenue or 40% of net revenue for the most consequential. This scale may suffice for this. Inherent and residual risks may then be calculated and compared by combining likelihood and consequence ratings before and after treatment. Risk evaluation. Enterprises may use their ratings of the likelihood and consequences of risks before and after treatment to evaluate residual risk levels against acceptable risk levels, that is, their risk tolerance. If the likelihood and consequences of residual risks is found to be greater than their risk tolerance, then enterprises need to devise further risk treatments to reduce the level of residual risk. Acceptable risk levels will be unique to each organization and supply chain. They may vary by commodity, product, or service, as well as over time. Different risk tolerance levels may be set for different levels of the organization. While generally tied to financial impact, through which risks may best be understood and compared, risks may also be tied to other corporate assets such as reputation. One leading firm even considers the consequence of potential risks by impact to stock price. The risk evaluation consists of the following key stages. First, select criteria. In many countries and industries, there is a wide range of established qualitative and quantitative risk criteria or standards for the evaluation of dangerous goods risks, including human safety and health, environmental and property risks. For example, risk criteria are developed in the chemical supply chain, including oil and gas inland and offshore industries, hazardous facilities, nuclear power plants, transport of dangerous goods, and in general, and health and safety. Risk criteria represent views, usually of the regulators, of how much risks are acceptable. In many countries, however, risk criteria reflect to a large extent the broad acceptance of society because, by law, a wide range of interests have a say in shaping criteria. It is an important task to identify and select relevant specific risk criteria for specific estimated risks in a specific country or industry. Responsible authorities or organizations have established certain sets of principles serving as guides for designing risk criteria in a specific country or industry. These principles cover a wide range of issues concerning risk and risk management, such as the basis for establishing threshold values of tolerable, intolerable risks, the frequency and magnitude of consequences of undesirable events, concentration of risks on particular individuals, locations and territories, the balance between risks and costs and benefits, and many more. In many countries and industries, risk criteria may be non-existent. Selection of risk criteria may also depend on the results of the risks analysis and how risks are estimated. In cases involving aggregated risks which combine two or more individual risks, the right risk criteria for evaluation of these types of risks are selected. Not all risk criteria available may be suitable for the evaluation of the aggregated risks. Second step, compare risks. In order to determine the significance or the level of estimated risks, at this stage estimated risks are compared against the selected risk evaluation criteria. Risk evaluation may involve different parties concerned with dangerous goods risks, including decision makers at senior levels. Risk evaluation also takes into account a wide range of additional factors and procedures other than scientific and technical ones. The theory on risk perception maintains that the concept of risk is strongly shaped by human minds and cultures. Numerous studies have shown that risk perception, evaluation, management, and attitudes towards risks are affected by a wide range of interrelated factors, including types of risks involved, benefits of risk sources, the type and the sensitivity of risk receptors, and systems and activities exposed. The ability of people to control risks, familiarity with risks, the equality of exposure to risk sources, concentration of risks, the type and the severity of consequences, and scientific uncertainty about the consequences. For example, large-scale disasters weigh more seriously in the public's mind than small-scale individual events. Society generally has a strong aversion to multiple casualty accidents. Next, we have to rank the risks. In cases involving various types of risks, the results of risk evaluation may show that risks have various degrees of significance. An important task in quantitative risk analysis is to relate risks to various system elements and risk receptors. In order to prioritize risk management strategies and measures and subsequently resources and efforts for managing risks, risks are ranked and prioritized according to their significances as well as sensitivity. The management index, which could be obtained from the sensitivity analysis, can be used for ranking risks with equal indices. Develop strategies and measures. At this stage, based on the result of risk analysis and evaluation, it is possible to develop and present a detailed list of risk management strategies and measures to deal with the present level of risks. There is a large array of approaches and means for dealing with the risks. Although the choices may be endless, there are generally a few principal management strategies, namely avoidance, elimination, reduction, transfer, and acceptance. The term risk management measure can be used as the most generic term representing the wide range of methods, techniques, approaches, or tools which, in contrast to risk management strategies, are employed for managing risks at a more operational or tactical levels. The figure you see here presents a classification of risk management strategies and measures. A single measure can be enacted to affect one or several risk or system elements. On the other hand, multiple measures can be designed to affect a single element. Often there is no single solution to guarantee a high degree of efficiency and effectiveness in risk management. As one single measure may not be sufficient, several measures are often combined to achieve risk management strategies. For example, mandatory technological and procedural measures can be combined with financial measures such as levies or subsidies. Certain risk criteria contain principal risk management strategies for various risk levels. In order to identify the most effective strategies and measures and to prioritize these, it may be desirable to formulate the set of strategies and measures, then submit these again for further scrutiny, including detailed risk analysis and cost-benefit analysis. The next step in the risk management process is risk treatment. Once an enterprise understands its supply chain and analyzes its potential risks, it can implement an effective supply chain risk management program with its partners, its suppliers, carriers, and logistics providers. Such a program should have at least three elements: protecting the supply chain, responding to events, and continuing business operations while recovering from the events. Let's now discuss each of these. First, protecting and securing the supply chain. An effective supply chain risk management program must ensure that an enterprise and its partners implement appropriate measures to fully secure goods and their components from the point of origin to final destination. Supply chain security is essential from two perspectives. First, firms need to prevent loss from theft or damage, and second, they need to prevent unauthorized intrusion into shipments that could enable insertion of contraband, loss of intellectual property or technology contained in the shipment, and tampering. Effective supply chain security and protection includes basic standards for physical security, access control, personnel security, education and training, procedural security, IT security, business partner security, and conveyance security from the point of origin to final destination within your supply chain. Enterprises and their partners may assess their effectiveness with these measures through self-evaluation. Let's discuss some benchmark standards for each of these criteria. Firms may wish to adapt or emphasize these in unique ways to reflect the unique risks they must address. For example, pharmaceutical and electronic goods companies may have high-value shipments that are at far more risk for theft than other commodities. Physical security. Suppliers, shippers, and logistics partners should have physical security deterrents to prevent unauthorized access to their facilities and all cargo shipments. Such features may include perimeter fencing, controlled entry and exit points, guards or access controls, parking controls, locking devices and key controls, adequate lighting and alarm systems, and video surveillance cameras. Access controls. They must prevent unauthorized entry to facilities, maintain control of employees and visitors, and protect firm assets. They should include the positive identification of all employees, visitors, and vendors at all points of entry and use of badges for employees and visitors. Firms should have in place procedures to identify, challenge, and address unauthorized persons. Personnel security. Enterprises and their partners should screen prospective employees in ways consistent with local regulations and verify employment application information prior to employment. This can include background checks on educational and employment background and possible criminal records, with periodic subsequent checks performed for cause or sensitivity of an employee's position. Firms and their partners should also have procedures in place to remove badges, uniforms, and facility and IT systems access for terminated employees. Education and training. Firms and their partners should establish and maintain a security training program to educate and build employee awareness of proper security procedures. Best practices include training on the threat posed by criminals, terrorists, and contraband smugglers at each point in the supply chain, as well as on ethical conduct and the avoidance of corruption, fraud, and exploitation. Enterprises and their partners may especially wish to ensure employees in shipping and receiving understand proper supply chain security measures. Education and training should also include documented procedure for employees to report security incidents or suspicious behavior. Procedural security. As noted, firms and their partners should establish, document, and communicate procedural security measures to employees. Such documentation may include a security manual, published policy, or an employee handbook. Documentation should include procedures for issuing accessing devices, identifying and challenging unauthorized or unidentified persons, removing access for terminated employees, IT security and standards, reporting of security incidents or suspicious behavior, inspection of containers before packing, and managing access and security to shipping containers. For shipping, such procedures should include security for shipment documentation, shipping and receiving and packaging. IT security measures should ensure automated systems are protected from unauthorized access and that information related to shipment routing and timing is protected. This should include password protection, including periodic changing of passwords, and accountability, including a system to identify any improper access or alteration. Business partner security. A supply chain security program must ensure that any supply chain partner, as well as any further subcontracted suppliers or logistics service providers, employ practices to ensure the security of all shipments. Any partner used in the manufacturing, packaging, or transportation of shipments must have documented processes for the selection of subcontractors to ensure they can provide adequate supply chain security. Suppliers should ensure that any parties handling shipments be knowledgeable of and able to demonstrate through written or electronic communication that they are meeting security guidelines. Conveyance security. Transportation, particularly drayage, inland track support, may be the most vulnerable point of the supply chain. Procedures that suppliers and shippers should follow include inspection and sealing of containers, storage of containers, and shipment routing through freight forwarders or carriers who are certified in a recognized supply chain security program, or who otherwise demonstrate compliance with a firm's supply chain risk management guidelines. Responding to events. Even with the best laid plans, enterprises may still confront crises in their supply chains. We characterize crises as events that threaten the organization with intense time pressures, high stress, and the need for rapid but careful decision-making. A crisis is an unstable condition involving an impending abrupt or significant change that requires urgent attention and action to protect life, assets, property, operations or income, the environment and reputation. Crisis events include natural disasters, major infrastructure failures, major fires, political unrest, labor disputes, pandemics, information technology failures, or security threats. Crisis management comprises the overall strategic and tactical responses of an organization to recognize and respond effectively, efficiently, and comprehensively to current threats. It involves proactive measures to detect, respond to, and recover from a crisis event. Crisis management preparation and response activities are characterized by several phases. First, preparation. Second, response, consisting of risk assessment, critical incident planning, risk mitigation, emergency response, and communications to internal and external stakeholders and media relations. Recovery and business resumption, testing, training, and plant maintenance. These processes are intended to enhance existing response capabilities by establishing a crisis management structure that will provide integrated and coordinated planning and response activities at all levels within an organization. They will also establish a common and consistent set of notification and activation thresholds. The structure and processes are designed to complement, not supersede, emergency response plans and procedures at various functional organization units and facilities. When an incident occurs, these units and facilities will follow established local response plans and procedures. Continuity of operations and recovery. Business continuity planning comprises those activities, programs, and systems developed and implemented prior to an incident that are used to mitigate, respond to, and recover from supply chain disruptions, disasters, or emergencies. It is an ongoing process, not a one-time project. A complete and tested plan gives an organization the framework to respond to effectively to an emergency. Focus on protecting employees and property, communicating to key stakeholders, and recovering and restoring the most critical business activities within an acceptable timeline. These plans should be integrated and tested alongside those of the relevant critical suppliers, customers, and other key stakeholders. To be effective, business continuity planning, also referred to as business continuity management, should be an integrated management process supported from the top levels and managed at both organizational and operational levels. A business continuity planning team should also establish company risk tolerance levels and recovery priorities, validate business recovery strategies, designate team members from each critical business function, ensure planning and documentation meets established timelines, and conduct periodic evaluation of the business continuity planning program as based on performance objectives. Let's continue with the fourth step of the risk management process, which is continual monitoring of risks. Once an organization has established a supply chain risk management program, including processes for identifying and treating risks, it should implement a monitoring program evaluating plans, procedures, and capabilities through periodic review, testing, post-incident reports, and other exercises. It should check conformity and effectiveness of the program, establish, implement, and maintain procedures for monitoring and taking corrective action as necessary. This includes reviewing other organizational changes that may affect supply chain risk management. Above all, organizations should test their plans periodically. Workers learn best by doing, hence regular testing of business continuity plans is necessary to ensure they will work when needed. Organizations may test plans in 4 ways, including an orientation or walkthrough to acquaint teams with the plan and their roles and responsibilities in it. A tabletop exercise to reinforce the logic and content of the plan and to integrate its decision-making processes and provide hands-on experience. This may entail presenting a team with a scenario and related events posing problems to solve. The exercise is designed to provoke constructive discussion and familiarize participants with the plan, their roles and responsibilities, and possible gaps in the plan. A functional test that creates simulations involving group interaction and actual disruptions in order to validate the key planning components and strategies. Such tests may include evacuation procedures. A full-scale test to evaluate the plan and response through interaction of suppliers and supply chain partners. Plans should be tested at least annually and preferably more often. Some organizations may concentrate on testing evacuation procedures, which, while critical, can exclude other elements. Testing and adjusting the plan. The goals and expectations of testing and exercises should include the following: determining whether a crisis response process works and how it can be improved. Testing capacity, for example, abilities of an emergency phone system. Reducing time to accomplish a process, like repeating drills so as to shorten response time. Increasing awareness and knowledge among employees about the risk management plan. Incorporating lessons learned from previous tests and actual incidents. Testing should occur at regularly scheduled intervals. It should evolve over time, starting as a relatively simple program but becoming increasingly complex as testing needs develop further. It should involve suppliers, customers, and other stakeholders as appropriate. The process should be embedded with the procurement contract terms and integrated into the supplier management processes. This figure here provides a framework for exercises and testing based on Plan, Do, Check, Act model. Testing, like the supply chain risk management process, begins with establishing the context, but also, like the supply chain risk management process, is a cyclical process. Both involve planning, following through on the plans, checking their performance, acting to improve their performance, and a reconsideration of how the results, as well as considering changes in the organizational context and how they might reshape the context, scope, and boundaries of supply chain risk management for an organization. Testing, evaluating, and adjusting their supply chain risk management programs can help organizations ultimately strike a balance between being able to respond to events while appropriately focusing resources to address the most likely and damaging risks. Areas of continual adjustment. Some risks, such as those posed by hurricanes and typhoons, may not change much over time. Other risks that organizations face, such as those inherent in their processes, suppliers, or their regulatory environment, can change. As a result, firms need to monitor risks and how to address them over time. As just one example of this, we will review the nature of regulatory risks and how organizations can respond to and monitor it. While perhaps not obvious at first, regulations can create significant supply chain risks. They can affect import and export documentation and compliance requirements, as well as shipment safety and security issues, and thereby affect shipment costs and create a risk for delays and financial penalties. Regulations can affect the countries or states in which an organization may work, as well as those in which its suppliers may work. In some, failure to monitor, shape, and respond to new regulations can pose significant risks for the supply chain. An effective risk mitigation program for legislative and regulatory requirements should help an organization monitor proposed or pending regulations, participate in the process shaping final regulations, plan and respond to changes in regulation, avoid compliance penalties, and ensure the smooth flow of incoming and outgoing shipments. In monitoring risks, organizations should seek to become aware early of proposed legislative and regulatory initiatives, understand how they might affect their business, and share with internal decision makers to determine a response. Some means to do this include establishing a government affairs function or assigning individual responsibility to monitor proposed legislation and regulations, creating an internal network of individuals who monitor regulatory issues, joining trade associations that monitor these and subscribe to their newsletters and bulletins, and developing other external contacts to monitor legislation and regulation changes. Monitoring should include assessing the risk of newly emerging regulation, tracking compliance with existing regulations, and identifying the points of the supply chain that will be affected by regulations. In responding to regulations, organizations should prepare in advance to avoid or mitigate the risks, including costs, delays, and penalties inherent in new regulations. While monitoring and seeking to shape pending regulatory requirements, organizations should develop, with early executive support and funding, an internal process or team or cross-functional representatives to analyze pending regulations and plan how to address each. For new regulations, organizations must communicate details to partners and help them otherwise prepare to support the new requirements. New requirements may also require organizations to update their contractual terms and conditions with their supply chain partners. Developing and implementing plans to monitor the supply chain as new regulations go into effect can ensure that compliant processes are in place and working. New regulations, like other evolving areas with which an organization must contend, can create significant risks for supply chains. These risks range from costs to delays to compliance penalties to still other areas. To be resilient, a supply chain must have the capacity to monitor, shape, and respond to evolving areas such as new regulations. The final step of the risk management process is risk communication. It has become an important integrated element of risk management. Risk-related information generated at each phase, stage, or step should be communicated continuously and effectively to all parties concerned. The literature shows that risk communication can be considered a specific domain of science in its own right. Risk communication in its role in attitudes towards risks, risk assessment, and risk management have been explored in several studies. For example, minor risks can sometimes produce massive reactions, while major risks often may be ignored. This is partly attributed to risk communication approaches. The public responses to risks can be amplified or reduced depending on how risk communication interacts with psychological, social, cultural, and institutional processes. Risk communication is an interactive process involving the exchange of information and opinions among risk assessors, managers, decision makers, and other parties, including individuals, groups, and institutions concerned. The interface among parties is a critical element for ensuring that risk assessment results are used to support the decision-making processes at all levels. Risk communication covers a wide range of activities directed at increasing the knowledge about risk issues and participation in decision-making and management. The process includes discussions about the nature and level of risks, risk management strategies and measures. In this process, people express their concerns, opinions, and reactions to legal and institutional bodies responsible for risk management. The public prefers clear information regarding risks and associated uncertainties and the nature and extent of disagreements among different experts in the field. Effective risk communication is an important responsibility of many industries and governments. The fundamental requirements of good risk communication practices include undertaking science translation, addressing uncertainties, and dealing with science and policy interfaces. A good risk communication program must consist of 4 elements. First, designing the strategy for a risk communication program, designing an effective risk communication message, rules addressing specific risk issues, and communication in crisis situations. In supply chain risk management, risk communication encompasses a wide range of activities, such as dissemination of risk-related issues, data and information, research results, sharing of best practices and experiences in the risk methodologies and management, holding public hearings on risk and risk management issues, providing information and warnings about hazards, and developing publicly accessible risk-related databases. Risk assessment processes and outcomes are required to be opened to greater participation and scrutiny by all parties concerned. This in turn has required the need to help the public understand information and to help decision makers understand the public's risk perceptions and responses. Perceptions and responses are complex, multidimensional, and diverse, as the public consists of many publics with diverse values and interests. Understanding public concerns must be the basis for an effective risk management strategy. Potential. Risk priority number, or RPN. These are used to prioritize the potential failures and are calculated as severity times occurrence times detection ranking. Actions recommended. The team should then select and manage subsequent actions needed to locate and control the situation. Now let's examine the predictive proactive methodology. The figure here depicts a predictive proactive methodology for managing supply chain risks. The methodology is represented by a process map associated with undertaking risk management and specifically supply chain risk management. The methodology assumes that for proactively managing risks, it is important to have sufficient information regarding the impending situation to aid the decision process on developing a mitigation plan. The predictive mode is hence reliant on the ability of the organization to provide sufficient and appropriate information. In the predictive mode, the focus is on acquiring data and analyzing it to discover meaningful patterns which will aid in identifying risks. The data gathering phase will engage with both the reactive and proactive approaches, as in accessing legacy data for a particular situation and projecting probable future scenarios. Various tools can be used in this phase. Data mining, as we described earlier, will be used to study legacy data for generating patterns of behavior causing risk, whereas FMEA will be used to project the probable situations for risk. These two tools together will provide sufficient data for the next phase. This is a very important phase as the analysis conducted in this phase will provide the necessary information for risk identification. The predictive mode enables the risk management agencies to form proactive solutions based on quantitatively analyzed data. Once the data is analyzed in the predictive mode, this data is fed into the proactive phase of the risk management process to enable the identification and quantification or effect of the risk scenarios. As seen in the figure, strategic objectives or objectives for the supply chain are at the center of the process and form the most important part of the complete risk management process. This depicts that the strategic objectives will control the risk management process and will also influence the solutions that will be developed for mitigating the risk. Referring to the figure, the event or the performance of the mitigating solution has an impact on the strategic objectives for further scenarios of risk management and will also influence the information that the risk management team has regarding sources of risk. This process is an iterative process as the cycle will repeat by studying new issues and risks identified after the analysis of the event. The new data will then be analyzed using tools identified in the predictive mode. In a proactive mode, there are two options for working with a supply chain. First, designing a new supply chain, and second, updating an existing supply chain. When designing a new supply chain or updating an existing one, the proactive mode will benefit in managing risks associated with the new situation. The predictive mode will provide sufficient analysis for identifying risks and quantifying their probability of occurrence and the impact. Also, information regarding the external and internal sources of risk in the form of security issues related to supply chain members, risk profiles for countries in which the chain operates, and risk profiles for individual members in the supply chain will be considered. These sets of information will then be used to determine the strategic objectives for the chain, and risk reduction and mitigation plans will be put together to meet those objectives. This, however, does not limit the existence of uncertainty, and there will be cases in which the mitigation plan will not be as efficient as required, or that a completely different scenario has materialized. Hence, it is necessary to update the strategic objectives and the data set of risk sources in line with the unexpected event or performance of the mitigation risk reduction plan. The methodology described here may look simplistic, but it does provide a process map for risk management. The focus of the methodology is to structure the two processes of data analysis and decision making. The stress on including the strategic objectives reflects the importance of providing benchmarks for the firm to base their future risk mitigation plans and to measure the performance of their plan against the possible events. Supply chain security. By blending organizational capabilities emanating from people, processes, and technology, the firm can embrace a supply chain security orientation and effectively protect itself and its supply chain assets from damage and/or destruction caused by internal and external threats. In modern times, many firms operate with constant concern that they are susceptible to human acts such as terrorism, sabotage, or theft, and often additionally worry that their differentiating assets are vulnerable to the effects of natural disasters such as hurricanes, floods, or other acts of God. Thus, it has become vital that firms take every prudent step toward securing themselves and their partners' future operations. Supply chain security and security management. Supply chain security and supply chain risk are two related, although discrete topics addressed by the dearth of publications to date focused on security-related issues. Terminologies pertaining to either security or risk have been used somewhat interchangeably. However, recent research is emerging that identifies these constructs as being distinctly different. Supply chain security is defined as the prevention of contamination, damage, or destruction of any supply chain assets or products. By contrast, supply chain risk is defined as the likelihood or chance of supply chain outcomes being susceptible to disruption which would have detrimental effects on the firm. The processes for managing both supply chain security and supply chain risk are interrelated as they are both involved in the promotion of the overarching concept of business continuity. The processes for managing supply chain security is known as supply chain security management, whereas the process for managing supply chain risk is known as supply chain risk management. Supply chain security management is defined as the application of policies, procedures, and technology to protect supply chain assets from theft, damage, or terrorism, and to prevent the unauthorized introduction of contraband, people, or weapons of mass destruction into the supply chain. By contrast, the definition of supply chain risk management includes the processes involved in the reduction of the probability of occurrence and/or impact the damaging supply chain events have on the firm. Supply chain security orientation. More recent research has begun to identify common business philosophies that effectively promote supply chain security as a prominent and necessary element for ensuring business continuity. The idea of supply chain security orientation represents an enterprise-wide attitude reflecting focus on supply chain security issues. Integrating both the security and risk management perspective, supply chain security orientation is a broadly accepted company orientation reflecting the firm's collective attention to both supply chain security management and supply chain risk management principles. Employees of supply chain security-oriented firms are posited as being concerned with both the potential for product asset contamination, damage or loss, as well as the potential for mitigating the likelihood and impact of disruptions between the firm and its supply chain partners. This group-level attitude is manifested as four core premises that are consistently mentioned as vital for firms seeking to maintain effective levels of security and in minimizing and managing supply chain risk. The key premises include preparation and planning activities, security-related relationships, organizational adaptation, and security-dedicated communications and technology. Securing supply chains through capability development. Increasingly, firms are devoting resources to the protection of themselves and their supply chains. To some extent, the increase in security-related investment in recent years may be attributable to well-known contemporary events that draw attention to the need for protecting company and supply chain assets. For example, the 9/11 terror attacks or Hurricane Katrina, and thus could be considered a key theme or pillar of supply chain security management. The resource-based view of the firm, or RBV, provides a basis for understanding the effectiveness and advisability of security-related investments designed to protect firm and supply chain assets. The RBV is a well-known strategic framework that speaks to competitive heterogeneity and associated advantages that stem from differences in internal organization across firms rather than industry characteristics and structures. The RBV is adaptable to the supply chain security context via a manipulation of the focal outcome variable rather than seeking supernormal profits. Firms practicing supply chain security management organize themselves such that they mitigate losses. In other words, RBV principles are suggested herein as applying in the security management context. But the role of security providing resources is to minimize losses rather than to maximize profits, though the overall focus on generating enduring industry advantage still applies. As the RBV has evolved into a widely accepted tool for explaining differential firm performance outcomes, it has become evident that simply acquiring and collecting resources is not a sufficient condition for firms to succeed. Firms' resources must be bundled intelligently with a given end purpose in mind in order to allow the firm to do things that its competitors cannot. The unique ability of a firm to perform a coordinated set of tasks utilizing organizational resources for the purpose of a specific end result is known as an organizational capability. In the context of supply chain security management, the development of organizational security capabilities may be what separates firms whose supply chains are breached from those that remain safe in the face of an impending risk. Drawing again from the strategic management literature, the development of supply chain security management capabilities may be properly identified as a dynamic capability. Dynamic capabilities are defined as the firm's ability to reconfigure resource stocks. These sets of organizational capabilities do not directly involve the production of the focal good or provision of a marketable service, but rather indirectly contribute to the success of the firm through their impact on regular operational capabilities. Supply chain security management capabilities are those dynamic capabilities that allow the firm to continue to perform operationally through protection of other firm resources such as plant, equipment, and human factors, and via this protection represent a differentiating factor for firms in the event of a disaster. Building supply chain continuity. Continuity planning represents the process of managing security performance throughout the entire supply chain. Building continuity into the future involves ongoing management of numerous aspects of the supply chain, which working together can serve to mitigate many supply chain risks and improve supply chain security, including the development of dynamic security management capabilities. Dynamic security management capabilities are resource bases that can be activated or deployed toward the goal of securing the firm's supply chain. They can be broadly divided into three categories: processes, technology, and human resource. These types of security management capabilities are depicted in this figure. Let's examine each one of them. Processes are the protocols and procedures followed by the organization and its supply chain partners. The fundamental aspect of building continuity into the future rests on well-constructed processes, which ensure integrity throughout the supply chain by providing monitoring, prevention, and responsiveness. It requires policies for everything, from supplier quality checks to inventory management to forecasting disruptions. One of the most important dynamic capabilities for the purpose of building business continuity is the capability of implementing processes or protocols for the management of the supply chain that offer effective security without compromising performance. This type of capability includes all processes within the organization as well as processes throughout the supply chain. Security must be built into each process, such that processes provide for supply chain visibility, an effective sourcing strategy, strategically managed inventory, the capability for redesigning products and processes with security in mind, and effective forecasting procedures. Technology involves the use of systems, tools, and machines that gather, process, and communicate data and information within and between firms. As such, they enable real-time monitoring and visibility of the supply chain. Finally, people are the human entities that implement procedures and use the technology in order to build continuity. Technology capabilities encompass tools and machines that can be used to solve problems. State-of-the-art advances in technology have led to its use as a dynamic capability in security management to provide communication and information flow throughout the supply chain, as well as global inventory and schedule visibility. A wide array of technologies is available that range from active telecommunications to traditional visual barcodes and labels to electronic sensors. These technologies permit shippers to track their shipments at all times, monitor their status, and provide network visibility that can prevent tampering and mishandling, as well as provide overall shipment integrity. In addition to these obvious security benefits, the use of technologies can provide other benefits, which include increased efficiency and productivity, reliability, and improved service quality. Human resources capabilities include organizational leadership. All of the organization's employees, suppliers, as well as government agencies responsible for putting into place programs that require security compliance. Building continuity into the future requires a comprehensive and holistic solution that is integrated across the enterprise and between end entities of the supply chain. As such, the three dynamic security management capability types, processes, technology, and human resource, cannot be managed independently of one another but must be designed to work together in unison. For example, technology capabilities must be developed and leveraged to support organizational and supply chain security procedures, and organizational members and suppliers must be trained in technology-related procedures and technology use with respect to security.